Hi everyone, my name is Nanapu Sirisha. I am studying in 4th semester in Computer Science and Engineering in Sri Venkateshwara College of Engineering. Today our subject is Discrete Mathematical Structure. Today our topic is Rules of Interface. Let me study about the introduction to rules of interface. Mathematical logic is often used for logical proof. Proofs are valid arguments that determine the truth values of mathematical statement. This is the small example of the rules of interface. Rules of interface are the fundamental principle that govern in logical reasoning. They provide a framework for drawing valid conclusion from the given premises. Importance of reasoning. Logical reasoning is the foundation of critical thinking and problem solving. It allows you to analyze the problem and we can validate the conclusion and make the logical reasoning skills abilities to native complex issue. Defining flow in arguments and communicate effective. Deductive and inactive reasoning. Deductive reasoning is a start with the general principle or premises and draw specific conclusion. It moves from the general to the particular logical step by each defining outcomes. Inductive reasoning means beings with a specific observation and identify pattern to formulate general theories or principles. It moves from the particular to the general, building upon arguments from individual cases. Logical validity. Both deductive and inactive reasoning rely on logical validity. The principle of sound will reason arguments. Strong logical reasoning is essential for critical thinking and problem solving. This is the small example of modus ponens. Modus ponens is the conditional statement and hypothesis of the conditional statement or truth table. Therefore, the conclusion must be true. The basic of modus ponens is the tautology, where premise case 1, if P is true, then Q is also true. In case 2, P is true. In conclusion, therefore Q is true. Modus tollens. It is a powerful rule of interference that allows you to draw a logical conclusion by negation. The consequent. If we know that a particular condition implies a certain outcomes Q, where we observe that the outcomes Q is not true, then we can infer that the original condition P must be a false, where in case 1, if P is P, then Q. In case 2, not Q. If Q is false, conclusion means therefore not P. Next is hypothetical syllogism. If the premise is true, then the conclusion is follow. In case 2, the premise is true. In conclusion, therefore, the conclusion must be true. Disjunctive syllogism, where it has the valid rule of interface that allow us to draw a conclusion when predict with the disjunctive premise. Either we can say negation of one of the P is eliminating the false. In rule of interface, some tautologies are rule of interface. The general form of a rule of interface is P, P2, so on, Pn, where P are the premises, C is the conclusion. Conjunctive and conjunction elimination, where conjunction is a logical operation that combines two or more statements into a single component statement, where conjunction elimination is a It is a rule of inference that allow you to break down the conjunction into individual parts. Then you know the A and B are the both true. If we conclude that A is a true and B is a true. In this application we are using conjunction and conjunction elimination are fundamental logical operation used in deductive reasoning, computer programming and decision making process. They help to simplify and analyze the complex statement. This is the small example of the conjunction elimination where negation and negation introduction, where negation basic is a logical operation that receive a truth value and statement. It is denoted by the symbol or the or not. If logical evaluation statement and its negation are logically equivalent, meaning they cannot be the true and false the statement, where negation introduction, the negation introduction rule allow you to induce a negation into proof of arguments when the opposite of the statement is true. Where negation application is a powerful tool to logical reasoning, allowing you to make a inference of and reach the conclusion based on the absence of opposite statement. Conclusion. The conclusion, we have explored the key rule of interface that form the foundation of logical reasoning. This principle, including modus ponens, modus tollens, and syllogistic reasoning, allow you to draw a valid conclusion from given premise. Understand the rule of critical of sound rational decision making.